Okay, welcome back. We're going to do an epsilon delta definition proof that a limit exists. To remind us of the definition of a limit of a function, I'll just show you the notation here. We're going to look at a function f of x. It may or may not be defined at a, but we're going to prove that the limit exists at a and that limit is L. And using a very formal definition, like in the picture, we're going to assume that function f of x exists. At least it exists for all x in some interval containing the value a, except possibly at a. We'll use the notation limit as x approaches a of f of x equals L if we can prove for any number, and I'm going to stress for any given number epsilon that is greater than 0, there is a corresponding number that we can find, delta greater than 0, such that this inequality implies this inequality is true. We're going to show the absolute value of x minus a being between 0 and delta will imply that the difference f of x minus L is less than epsilon. Alright, okay, so an example. Let's look at the function 3x plus 5. And let's show that the limit as x approaches 4 of the function 3x plus 5 is 17. Okay. Thinking back to the definition we just looked at, we need to show, given some epsilon, we can find a corresponding delta such that the inequality x minus 4 in absolute values, that if the absolute value of x minus 4 is between 0 and delta, that's going to imply that f of x, which is linear, minus the limit 17, that difference will be less than epsilon. Okay, so just mainly I wrote that out to show that in this example a is 4, so we have x minus a. The function is 3x plus 5, and that shows up here. And we have f of x minus L, and L was the 17 here. Now, writing a proof usually happens in two parts. Step 1 is doing some calculations that helps the writer figure out what delta is. So we're going to calculate or find delta. And it won't be a number, it'll be a function of epsilon. We're going to write down a relationship between delta and epsilon that will help us show this implication. Okay, so step 1 is doing some quick algebraic calculations, and step 2 is a formal proof. To get started in step 1, look to the expression f of x minus L in absolute values. Write that out and simplify the expression inside the absolute values. Okay, well, 3x plus 5 minus 17 will simplify, and we'll get the difference 3x minus 12. And for the most basic proofs, it's going to turn out that this expression is related to the expression up here that describes delta. Can you see a relationship between the difference x minus 4 and the difference down here in brown, 3x minus 12? Yeah. The brown expression is 3 times this green expression. So that prompts me to factor this expression. I'm going to factor out absolute value of 3. Since absolute value of 3 is just 3, my original absolute value is equivalent to the product 3 times x minus 4. And with practice, we'll learn that this is exactly how we write delta in terms of epsilon. Since we have this relationship 3 times x minus 4, it's going to be reasonable, it is reasonable, to define delta as epsilon over 3. Okay. And you'll see later in the proof how this works out. Since this difference is 3 times this difference, epsilon is reasonably 3 times delta. And I just rewrote that so that we can define delta. Right. Step 2, the formal proof. This is what your instructor will want you to be able to demonstrate. I'll pull out another piece of paper here. Okay. Step 2. This is the actual proof. We must assume that some epsilon has been given. It's an arbitrary number, probably some small number, but it can be anything. From our calculations above, we've chosen to define delta as epsilon over 3. And now we look at the assumption 0 less than the absolute value of x minus 4 being less than delta. And we see what that implies. Okay, this is going to feel similar to the calculations above. We're going to write down f of x minus L for the reader, which is our linear function 3x plus 5 minus 17. And we know how that simplifies. The inside expression simplifies to 3x minus 12. And we know we can factor out the 3. And now here's the logic. If we have already assumed that the absolute value of x minus 4 is less than delta, then down here, 3 times absolute value of x minus 4 must be less than 3 times delta. But we've also assumed delta is epsilon over 3, so 3 times delta is 3 times epsilon over 3, which reduces to epsilon. Now, using the transitive property of inequalities, we have shown that this difference is actually less than epsilon by the transitive property. F of x minus L in absolute values is less than epsilon. And that completes the proof. Okay, and so just in summary, we assumed epsilon was positive, we found a corresponding delta, and upon assuming absolute value of x minus 4 was less than this delta, we showed that this difference was less than epsilon, and that's how to prove the limit exists according to the definition. Appreciate your attention.